Hello, this is Professor Blackman. Welcome to Lesson 5.5. In this lesson, we're going to talk about solving rational equations. So in previous episodes, we've talked about fractions and how to get rid of fractions using the LCM. Well, that's what we're going to do now and use that instead of adding or subtracting them, we're actually going to take and solve them because these are equations. Uh, at the bottom on this page, you'll see that I have a couple of examples. After you watch the video, I do recommend you work through these examples and see if you get the same answers. There's a good variety in these three, and I think they're just worthwhile of working out. All right, let's go ahead and get started. All right, so uh, as you see here, we have fraction, fraction, fraction. And so we've got to get rid of this fraction. So we're first going to start out by looking for the LCM, or least common multiple. A lot of people will talk about like an LCD. It's the same thing, except we're using it to multiply to eliminate the fractions. So what number does 3, 6, and x all go in? Let's look at the LCM. So the LCM is the least common multiple. It's very similar to the LCD, except we use it to multiply to eliminate the fractions. So if we look at these numbers, we have 3, 6, and x, all these terms in the denominator. 3 is 1 times 3. 6 is 2 times 3. And x is just x. So 3 is represented in 6 here. It's represented here, so it's already counted. X is not counted anywhere, so we need an x here as well. You multiply all that out, you get 6x. So 6x is our LCM. So that is what we're going to multiply every term by. So I'm going to do 6x times 2/3 minus 6x times 5/6 equals 6x times 1 over x. And we can cancel as we go by. 6 cancels 6, x cancels x. 6 and 3, 6 divided by 3 is 2. So this will become 2x. And now we can multiply what's left. 2x times 2 is 4x, minus x times 5, 5x, and 6 times 1. So that's 6. 4x minus 5x gives you negative x equals 6. Divide both sides by -1, and you get x equals -6. Now, it's very important with rational functions that you're always checking your work because at any time, if your solution makes your denominator 0, which in this example 1, the only way to get 0 is if x is 0, which it's not. We're saying it's -6. But it's just always a good habit to just go ahead and check. So let's take 2/3 minus 5 over 6, and that needs to equal 1 over -6. So we put this, multiply by 2, and we get 4 over 6 minus 5 over 6. And 4 minus 5 is -1, so we end up with a -1 over 6. So this is checked. Always a good habit to do that while you're working, especially with rational equations. All right, let's look at our next example. All right, so both of these are x minus 2. So that makes this one very simple when we take and multiply both sides by x minus 2. So when we multiply here by this x minus 2, that cancels and that cancels. And so then we get x squared equals 4. A lot of people will see this and they'll just immediately jump to the answer of 2. But if we take this as a quadratic and we solve it by factoring, remember that x squared, positive or negative, will both give you 4. So then we get x minus 2 equals 0, x plus 2 equals 0. So x equals 2 and x equals -2. So let's go ahead and look back here at the original problem. And so there are restrictions here on this domain. What value of x will make this equal to 0? Um, so if we take and set x minus 2 equals 0, we get x equals 2. That's my denominator here that I'm doing. So x cannot equal 2. If x equals 2, we divide by 2, which is we divide by 0, which is undefined. So x equals 2 cannot be a solution. This is what we call an extraneous solution. So in this case here, our only answer is x equals -2. Now, of course, we can go ahead and check this. Go ahead and check this just out of habit. It's always good to just go ahead and check. So -2 squared over -2 minus 2 needs to equal 4 over -2 minus 2. Well, these two denominators are the same. We just need to make sure this top is the same. And -2 times -2 is 4. So we have 4 over -4 equals 4 over -4. They are the same, so I know this is correct. All right, let's go ahead and look at our next example. All right, so we first need to start by looking at what the LCM is here. So here we have x minus 3, we have x, and x squared minus 3x. If we quickly go ahead and solve this, factor this, so we can solve, we get x squared minus 3x. So as you see, this factor is here and here. So this is what our LCM is. A lot of times that will happen in problems because it just gives you less factors to work with. So we need to multiply each term by this x minus 3. So we're going to multiply the first term minus, multiply the LCM by the second term, and we need to multiply by the term on the right side, the 18 on top, and the x squared minus 3x on bottom. So we quickly know that everything in this right term cancels out because it was our LCM. We're going to cancel out this x, and we're going to cancel out this x minus 3. As I've mentioned in previous videos, I like to take my subtraction problems and make them addition problems, so I'm going to move that -6 up. Now let's multiply out and see what we got. 2x times x is a 2x squared. And then we have -6 times these two terms, which is a -6x and a plus 18. And all this canceled out, so it's just the 18 on the right. So I can quickly subtract 18 from both sides and zero out the right side because this is quadratic. So then we have 2x squared minus 6x equals 0. I'm going to go ahead and I see that everything here are even numbers. So I'm going to just divide by 2, make my numbers easier to work with. So then I have x squared minus 3x equals 0. Factor out at x, the GCF that's here, and I get x minus 3. And now I can set each of these equal to 0. First term is 0. And second term is add 3 to both sides, you get 3. Now I quickly need to look, will any of these make my solution, any of these make my original problem a 0 in the denominator? If I plug in 0 right here into that 6 over x, 6 over 0 is 0. So this is not a solution. Take x equals 3, plug that into 3 minus 3, that gives it 0 in the first fraction. So this also 0. So we got two solutions. Both of them were extraneous. So we would say no solution. All right, let's look at our next example. So first off, we need to look at what our LCM was. And if you put a 1 over all of these, you can just see it's 1x and 1. So our LCM is just x. So we need to multiply each term here by x. And that will cancel out this middle term, the denominator in the bottom. So that's x squared plus 8 equals negative 9x. Add 9x to both sides because this is a quadratic and we need to zero out one side. We get x squared plus 9x plus 8 equals 0. Two numbers that multiply to give you 8 add to give you 9. That's 8 and 1. Solve this, each one individually, set them equal to 0. And we get x equals negative 8 and x equals negative 1. And our only restriction on our domain, which would make our denominator 0, is when x is 0, neither one of these are a solution. So our solution is negative 8 and negative 1 here. All right, let's look at our next example. All right, so in this one, start by looking at the LCM. And so we have x minus 1, x plus 1, and if we factor this out, we get x plus 1, x minus 1. So that is what our LCM will be. And we can go ahead and look, since it's already factored out here, we can say that when we are done, x cannot be negative 1 or 1. Because if it's 1, that's 0. If it's negative 1, that one's 0. If it's negative 1 or 1, the middle one is 0. Okay, so now let's go ahead and multiply by the x plus 1, x minus 1 to each term. Okay, so we have 2x plus 3 over x minus 1. We know that'll cancel out. Equals 10 on top, x squared minus 1. We know that whole thing will cancel. Plus 2x minus 3 over x plus 1. So the x plus 1 is going to cancel out. So now I need to multiply this term here by each term and this term here and this term here and this term here. You know, using the FOIL method. It got a little messy. All right, so x times 2x is 2x squared. X times 3 is 3x. 1 times 2x is 2x. And 1 times 3 is 3. Over here, we just have a 10. And over here, x times 2x, 2x squared. X times negative 3 is negative 3x. Negative 1 times 2x is negative 2x. And negative 1 times negative 3 is a positive 3. So if I subtract 2x squared from both sides, that cancels out. If I subtract 3 from both sides, that cancels out. And so now I'm going to simplify. I have 5x on the left and negative 5x plus 10 on the right. Add 5x to both sides, add 5x. You get 10x equals 10, divide by 10, and x equals 1. And earlier we said x cannot equal 1, so this one has no solution. All right, let's go ahead and look at our next example. All right, let's start by identifying our LCM. This is pretty similar to the one we did previously. We have x minus 2, x plus 2. If we factor this out in the middle, we can see it also has it as well. So our LCM is x minus 2, x plus 2. which means our restrictions on our domain mean x cannot be -2 or 2. Okay, so let's start by multiplying the LCM by each term. So then x minus 2 will cancel out, so we'll have x times x plus 2 plus cancels out everything, leaving just the x. X plus 2 cancels out, leaving x minus 2 times x plus 3. All right, distribute, we get x squared plus 2x plus x equals FOIL. We get x squared plus 3x minus 2x minus 6. And just like before, if we subtract x squared from both sides, that's gone. 2x and x, let's go ahead and combine like terms. We get 3x equals x minus 6. Get your variables to one side. We get 2x equals -6. Divide by 2, x equals -3. Let's go ahead and check this one. It's just, like I said before, it's always in a good habit to check it. We're going to quick check this one. I'm going to plug in and simplify at the same time. If I plug in a x to -3, I get -3. -3 minus 2 is a -5, plus a -3 on top. Bottom, -3 squared is 9, 9 minus 4 is 5. On top, -3 plus 3 is 0. On bottom, -3 plus 2 is a -1. So you have negative divided by negative is positive, so you have 3/5 minus 3/5 equals 0. And that is in fact true, so this one is correct. All right, let's go ahead and look at the next example. All right, again, let's start by looking at the LCM. Now, in this one, we have some that are not factored, so we definitely want to go ahead and factor it. Two numbers that multiply to give you 3 and add to give you a -4. That's x minus 3, x minus 1. So we already see the x minus 3 in the second term. Let's go ahead and look at this third term. 4, factor out of the GCF 4, you get x minus 1. So you see x minus 1 occurs in two terms, x minus 3 occurs in one term, and this 4 is just by itself. So we put it all together. That would be our LCM. Okay, so I'm going to do this one by writing it all out again. Over 6 over x squared minus 4x plus 3 minus 1 on top after we multiply by the LCM. X minus 3 on bottom equals LCM with a 1 on top. This problem, because it puts the 1 on top, it makes it a little easier mathematically. So now let's start canceling. As always, I take my subtraction problems and make them addition by moving that negative up. We know that this factors, so all we need to do is multiply by 4 there. X minus 3 cancels there. And 4 and the 4 here and the x minus 1 cancels here. So as we multiply this, we have 4 times 6, which is 24. And then a -1 times a 4, which is -4. So -4 times x would be -4x. And -4 times a -1 would be a +4. So that's everything on the left side. Now let's look at the right side. Canceled out, and we just have x minus 3 times 1, which is x minus 3. Okay, let's go ahead and get our x's to one side, combine like terms. -4x plus 28 equals x minus 3. I'm going to add 3 and add 4x. And now I have 28 plus 3, which is 31, equals 5x, because that cancels and that cancels. And divide both sides by 5, and we get x equals 31 over 5. If you are using a program like MyLab Math, make sure you put this in as the fraction 31 over 5. Do not put it in as a decimal. MyLab Math will always mark it wrong. It almost always wants fractions. All right, let's go ahead and look at our next example. All right, let's go ahead and look at this one. So we need to figure out what our LCM is first. So we already have y plus 3 and y minus 3. So it's kind of this middle term we need to figure out what factors it's made of. I see that there are both multiples of 4, so I'm going to factor that out. And that gives me y squared minus 9. And we know that that will factor to y plus 3, y minus 3. So that's what our LCM is, 4, y plus 3, y minus 3. And we can look at our restrictions. What cannot this not equal for our solutions? And we know y should not equal -3 or 3, because that will make our fractions have a denominator of 0. All right, so let's go ahead and multiply our LCM by everything that's there. If I multiply this first one by y plus 3, then I have 4 times y minus 3 times 5 equals, this whole middle term is our LCM, so that's just going to be 1, plus, cancel out a y minus 3, you get 4y plus 3 times 2. Okay, 4 times 5 is 20. So I'm going to do that first and then multiply. So 20y minus 4 times 20 times 3, 60. 1 has nothing to be multiplied by. 2 times 4 is 8. So again, I'm going to multiply that and then multiply those. So that gives me 8y plus 8 times 3, 24. All right, so from here I need to combine like terms, 0 out one side. So I'm going to combine like terms first. 8y, 1 plus 24 is 25. Okay, so this is not, this is a linear problem, so we just need to get y's to one side, everything else over to the other. So subtract 8y. That will get rid of the 8y's on this side, add 60. That will cancel out the numbers on that side, so then we end up with 12y equals 85. Divide both sides by 12, and we get y equals 85 over 12. I know those are big numbers, but it's not going to simplify. So that is our last example today for solving rational equations. Good luck on your homework, and remember, happy studying.